Hi guys, so I got cut off right there at the end. So really quickly, I just wanted to go through and create this video for you just in case you needed any additional help with plotting the points after we create these equations or just generally creating these equations. I wanted to make sure that you had this video so that you could better understand those things. So this video is only going to go through number 5. The previous video went through numbers 1 through 4. So let's take a look at number 5. It says Jessica and Carl run at constant speeds. Jessica can run 3 miles in 24 minutes. Carl can run 2 miles in 14 minutes. They decide to race each other. As soon as the race begins, Carl trips and takes 2 minutes to recover. Write the linear equation that represents Jessica's constant speed. Make sure to include in your equation the extra time that Jessica was able to run. All right, so remember that we can simply write our linear equation for Jessica as y equals 3 over 24x. But we are able to reduce this equation because 3 goes evenly into 24. So 3 over 24 becomes 1/8. So y equals 1/8 x. But we're not done. And the reason I'm not going to put x is because Jessica had a 2-minute 2 minutes extra on her time. So I'm going to put x plus 2 compared to Carl, whose linear equation is simply y equals 2 over 14x, which we can reduce that fraction to y equals 1/7 x. So that is Carl's equation, linear equation. Now for Jessica, we need to finish it off by multiplying both of these numbers inside of our parentheses by 1/8. So we have y equals 1/8 x plus, remember we're multiplying straight across, so we have plus 2/8. And we can reduce that 2/8. So our final equation is y equals 1/8 x plus 1/4. Okay, so we're going to create a system of linear equations to represent this situation simply by writing our equation for Jessica, which is y equals 1/8 x plus 1/4, and our equation for Carl, which is y equals 1/7 x. So that's our system of linear equations, which we're now going to turn to the next slide to graph. So I'm going to move forward to graph these two equations. So Jessica's equation is y equals 1/8 x, 1/8 x plus 1/4, and I'm going to represent Jessica with black. And Carl's equation is y equals 1/7 x, I believe. Yes, okay. So we need to graph these two equations. Now remember, the first point that we plot in terms of linear equations is the y-intercept. So for Jessica's, it's a little bit easier for us to know what the y-intercept is because it's written right there for us. It is 1/4. For Carl, it's just as simple, but we can't see that y-intercept. So for Carl, remember there's an imaginary 0 right there. So we're going to plot the point on the y-axis where that line is going to cross the y-axis at 0, 0. For Jessica, her point is going to cross the y-axis at 1/4. And 1/4 is 0.25, so I'm going to plot my point just above 0.2. So there's my point. Now, it's going to be easier to graph Carl's because I'm literally going to move from 0, 0 up to 1 and move over to the right 7 units. So 1, 2, 3, 4, 5, 6, 7. So here is my next point. I'm going to move from there up 1 unit, so up to 2, and move over 7 units. 1, 2, 3, 4, 5, 6, 7. And now I can connect these points to create this graph or this line of this equation to represent Carl's linear equation. And what I'm now looking for is the point where my line for Jessica is going to cross my line for Carl. So now I'm going to plot those points for Jessica. So now from 0.25, I need to move up 1 unit and over to the right 8 units according to the slope of my equation, which is 1/8. So I'm going to move up now to 1.25, and I'm going to move over to the right 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. So here's my next point. And from there, so from 1.25 plus 1, I'm going to move up to 2.25. So here's 2.25, and I'm going to move to the right 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. And it takes me kind of right into the middle of this box here. So I'm going to connect these 3 points to create this line for Jessica. I'm a little bit off, but that's all right. This line for Jessica of where and so that's going to help me understand where my points are crossing. So my points are actually crossing a little bit higher up, but I'm going to use this point right here, which is totally okay. So we're at 15, and let's say 2.1. So I'm going to move on to my next slide, and it says use the graph to answer the questions below. If Jessica and Carl raced for 3 miles, who would win? So if we come over here and we're looking, well, 3 miles is not on our graph. So it's clear that Carl is going to win because his line is going up at a steeper rate than Jessica's is. But we can use our equations to answer these questions as well. So remember, Jessica's equation is y equals 1/8 x plus 1/4. And remember that miles are a y value. So we're going to plug in 3 for y and solve for x to determine Jessica's time, because remember, time is x, for completing 3 miles. And then we're going to do the same thing for Carl. So remember, Carl's is simply y equals 1/7 x. And so we're going to plug 3 in for y, and we're going to solve this equation. So in order to solve for Jessica, we're first going to subtract 1/4 from both sides of this equation. And remember, if I currently have 3 over 1 and I'm subtracting from that 1/4, so I need a common denominator. So I'm going to multiply the top and bottom of my fraction by 4. So I have 12 over 4 minus 1/4, and 12 over 4 minus 1/4 is equal to 11/4. So now I'm left with 11/4 equals 1/8 x. And since that 1/8 is being multiplied by x, I am going to divide both sides of this equation by 1/8. And remember, when I divide fractions, I flip the second fraction, so I actually have 11/4 multiplied by 8 over 1, which gives me 88 over 4. And when I divide 88 by 4, I get 22. So it's going to take Jessica 22 minutes to travel 3 miles. As far as Carl goes, I need to simply divide both sides of my equation by 1/7 because that x value is being multiplied by that 1/7. And so now I have 3 over 1, and I'm going to flip that 7 over 1. So I actually have 21 over 1. So Carl is going to travel those 3 miles in 21 minutes. So we can say Carl would win because his time is shorter. He will get to the 3 miles faster, 1 minute faster than Jessica will. So it asks us for number 2 for part E, at approximately what point would Jessica and Carl be tied? So if we go back to our graph and we look at this point where our 2 lines are crossing, we see that they're crossing at 15 minutes and 2.1 miles. So we're going to say 15 minutes and 2.1 miles. And so we would represent this as a point as 15, 2.1, meaning the solution to our system of equations is 15 and 2.1. So hopefully that helps you a little bit in understanding systems of equations a little bit better. If it doesn't, please send me an email. If you're confused about anything, send me a text message or an email, and I'll be happy to help you. You guys have a wonderful day. Thank you.